Hi, welcome to another session of Principles of Steel Design. So for this session, we will be talking about the design of philosophies and load combinations that we will be using for the entire course this semester. Alright, but first, we need to define kung ano ba ibig sabihin ng design philosophy. So, design philosophy refers to a set of principles, guidelines, or approaches that we engineers and designers try to follow to guide us in our decision making process during the design of a structure. Okay, so basically, si design philosophy is a way of thinking ng mga designers on how to tackle yung mga different approaches na gagawin niya when designing yung mga components ng structure natin. It represents nga a systematic way of thinking about how we will address yung mga problems na kailangan natin bigyan ng solution. So in an essence, pag sinabing design philosophy, it serves as a framework that influences yung overall approach natin as designer kapag hinahanap natin yung particular solution sa mga specific problem or project na i-handle natin. So tinutulungan tayo i-ensure ng design philosophy na ma-meet natin yung safety standard, functional requirement, and any other criteria na essential for the intended purpose ng structure natin or system. So basically, it dictates how engineers should analyze loads, determine material properties, and ensure the safety and functionality of a structure. Okay? So, in choosing a particular design philosophy, it influences yung consideration natin ng mga limit states na tinatawag natin during the structural design process. Pero what does limit state means? So limit states refer to a specific condition or state that the structure should be able to withstand without compromising its safety, functionality, or serviceability. It means na kapag sinabing limit state, ito yung pinaka-extent na design ng mismong structure natin and ayaw natin na ito yung ma-achieve na value ng structure natin kasi once na na-achieve o na-exceed niya yung value na makakalculate natin under these limits, it means na hindi na serviceable, functionable, or useful yung structure natin. Kaya dapat itong mga values na to should not be attained by our structure or when our structure is subjected to a particular loading, it should not feel or have the value that we have calculated dito sa mga limit state na to. So when we talk about limit state, we are generally talking about two categories. Number one is yung ultimate limit state and number two is yung serviceability limit state. Okay? So let us first discuss yung ultimate limit states. So for ultimate limit states, it represent yung extreme conditions that a structure must be able to endure without collapsing or failing catastrophically. No? So this means na pag sinabing ultimate limit state, ito yung ayan nga, as indicated, um, ultimate limit under extreme conditions. So extreme conditions like yung mga natural calamities natin like earthquakes, severe storms, or very um, high typhoons, no? Or for the case of bridges or roadway natin, maximum expected traffic loadings natin. So it means na when we are talking about ultimate limit state, we are looking at the whole structure in general. So yung kabuuan ng structure na ang gusto natin ma-identify yung value na kailangan nating i-prevent during design. Okay? So dapat itong value yung makakalculate natin under this limit state when our structure is subjected to these extreme conditions should not be met by our structure kasi once that they are met, maapektuhan na yung performance niya as a whole structure. And then, under yung ultimate limit state, we have yung tinatawag nating strength limit state. So si strength limit state, ang kaibahan niya, it focuses specifically on our structural elements. So when we talk about structural elements, this deals with our beams, columns, or connections ng steel structure natin if we are talking about steel, ano? And isa lang naman yung purpose din niya or yung goal din niya. That is to possess dapat yung ating mga components sufficient strength to resist yung mga applied loadings natin without failure. So yun yung kailangan nating ma-achieve. Ano? Dapat hindi siya mag-fail even nalalapit na siya dun sa mga limit values na sinet natin or na-calculate natin under this limit states. Okay? And then, we have yung serviceability limit state. So, serviceability limit state focus on ensuring na yung structure natin remains functional and meets acceptable performance criteria under normal conditions throughout its lifespan. So, the same same scenario or example that we have last time. Now, when we say serviceability, let's say we are designing school buildings or hospital, even a disaster happen, this type of structures should also uh, be functional kasi they serve as an evacuation center para dun sa mga school building natin and for our hospital na sila yung nag-aid ng mga uh, communities na maapektuhan ng mga extreme conditions na nabanggit natin dun sa ultimate limit state. Kaya pag sinabing serviceability limit state, an example of that is maintaining acceptable levels of deflection, vibration, or cracking na hindi nako-compromise yung intended use ng structure natin. Kaya parang sinasabi niya na halimbawa we are designing a beam. No? So if being stressed yung structure natin, kailangan kahit may nakikita tayong cracking dun sa beam natin or deflection, it should still be acceptable or within dun sa limit natin. Okay? Or dapat functional pa din siya as a whole. Okay? So, yun yung serviceability. And then when we talk about design philosophies, for still, we have three approaches that we can dive into. Number one is yung allowable strength design. We have plastic design and also yung load and resistance factor design. So we will try to discuss one by one first. But for our course, we will just be focusing on number one and number three, which is yung ASD and load and resistance factor design. Okay. So for allowable strength design, so or ASD, so basic lang yung kanyang requirement. Okay? So in a nutshell, ang gustong sabihin ni ASD is mag-set tayo ng limit for a stress halimbawa and i-design natin o i-make sure natin na yung component natin will stay below nung limit na yun. So once na na-achieve mo yun o na-follow mo yun, your design would be safe or acceptable siya. Okay? Kaya ang tawag dito sa design philosophy na to, traditional or classical design methodology siya. Okay? Kasi once na you are knowledgeable enough dun sa value ng mga allowable stresses of a certain material, ang goal mo lang is wag maabot yung values na yon para magstay siya within the acceptable design ng component natin. Also, it is known as elastic design or working stress design. So, as we have discussed from our previous topic, when we say elastic yung material, it tends to return back to its original shape. Once na after loading it and then kapag tinanggal natin yung load, ang assumption is it returns to its original state. So, ito yung concept din na ginagamit from the start nung concrete design din dun sa yung working stress design. So whatever is the loading of the structure, ang ginagawa ng designers before is they will just design the structure based from the approximated loadings na mag-occur dun sa mismong structure natin. Okay? Then ASD relies on predetermined allowable stresses for materials. So engineers calculate yung load and just compare them to these allowable stresses to ensure that yung structure natin remains within safe limits. Okay? So later, may consideration yung ASD to give allowance doon sa allowable stress na tinatawag natin. And ang ginagawa niya, gumagamit siya ng tinatawag na factor of safety. Okay? So later, i-dive natin yan. Pero ASD is somewhat conservative daw siya. Okay? Kasi it focuses on preventing yung structure from reaching a stress level that could potentially lead to failure. Okay? Kasi nga, ang goal natin, below lagi tayo ng limit. And yung ginagawa ni ASD is mentioned dito sa statement na to. A member is selected na may cross-sectional properties like area and moment of inertia na large enough siya to prevent yung maximum applied forces from exceeding an allowable or permissible value. So, to accommodate yung possible na mga uncertainties or human error when hina-handle na natin mismo yung material na gagamitin natin, ang sabi ni ASD, yung allowable strength nung nung material natin or yung tinatawag nating capacity of our material. So, what they do is they are dividing it by a factor or yung factor of safety ang tinatawag, natatawagin nating omega. So, si factor of safety is usually greater than 1.0 siya. So, um, this is to accommodate for any uncertainties, ano? So, as mentioned, one example is human error or defect ng material or pwedeng yung workmanship of our workers on site. So, the code tries to account for those uncertainties. And one way of doing that is dividing it by a factor of safety greater than 1.0. So once we try to divide itong allowable strength natin by a capacity greater than 1, what happens is nagre-reduce yung ginagamit natin for design. Okay? So let's say you have a 5,000 PSI concrete and then you assume a 2.0 factor of safety. So when you are designing, hindi 5,000 yung gagamitin mo as your allowable strength. Ang gagamitin mo lang is hanggang 2.5. And then, ang mangyayari, lahat ng loadings mo na acting on your structure, na dito yung papasok sa required strength, o ito yung actual loading natin, i-assure natin na dapat hindi siya lalapit or it should be less than or equal dun sa 2,500 PSI na allowable stress na na-calculate natin based from the factor of safety that we have applied. So, yun lang yung gustong sabihin ni ASD. However, this approach or this design philosophy has its disadvantage din, ano? Since yung sa actual loading niya is they are not doing anything from it, ano? Hindi ma-accommodate ni ASD yung full potential or yung possible variations dun sa loading natin. Let's say for example, in a given structure, nag-set tayo ng value ng live load. Okay? Pero live load, especially halimbawa for example, a classroom, let's say for the design, you are just expecting 40 student dun sa design mo yung weight na i-accommodate niya. Pero in reality, more than 40 student are using yung mismong structure mo or sometimes um, more than 40 yung nakakapasok sa kanya. So, ibig sabihin, yung mismong live load mo is hindi niya ina-account yung possible overloading that the structure is experiencing once na merong extra number of students na present dun sa mismong room natin. So, yun yung isa sa nakita ng mga scientists and engineers before na we can do better uh, dun sa design philosophy natin. That is why nag-arise yung other two philosophies to accommodate yung uncertainties that they have um, observed dun sa actual loadings na present dun sa structure natin. Okay? Kaya dyan papasok yung dalawa. So, yung first is yung plastic design natin. So, for plastic design, yung design philosophy na to is based on a consideration ng failure condition rather than yung working load condition natin. So when as mentioned dun sa stress and strain curve discussion natin, when our material is in plastic condition, it means na even though we are not increasing our loading, our material is already experiencing uh, permanent deformation, and it continues to increase as times goes by. So in steel design, plastic design is being used also kasi from what we have learned, si steel is a very ductile material. So even though nagkaka-experience na siya ng deformation, usable pa din yung strength niya. So it still possesses some strength. And then according to the graph, after yung plastic behavior niya, our material will attain pa its ultimate strength. Kaya um, some say na si plastic design is much better dun sa other two design philosophy. However, si plastic design kasi is um, a new concept or hindi pa siya masyadong ina-apply on the general structure na kino-construct. So basically, hindi pa siya ina-apply talaga sa practice ng karamihan kasi they are bound to the old-fashioned design which is yung ASD, and then they are still using yung more sophisticated design philosophy which is yung LRFD. So say plastic design for our case, we will not focusing on plastic design. So if we are still fortunate enough during the end of the course, if we still have time, we will try to have examples in plastic design. Kasi this particular design philosophy um, is somehow, some say na mas nakakapagbigay siya ng mas economical section, especially kapag consider natin yung behavior ng component natin during uh, plastic failure na. Okay? So yung design procedure niya is roughly as follows. So minumultiply yung working loads by the load factor to obtain yung mga failure loads natin, and then determine yung cross-sectional properties according to this failure loads. Okay? So ibig sabihin ang ina-assume niya talaga is yung uh, pinaka-extent na loading na pwedeng i-carry ng isang component, and then tsaka niya isa-select yung lightest cross-sectional shape that has these properties. Okay? So, kaya nga, ang consideration niya or ang kanyang focus is yung failure condition ng component natin. Okay? Then, ang last nating design philosophy is yung load and resistance factor design. So, this philosophy is similar to plastic design in that strength or the failure condition is also considered. So, by the name itself, load and resistance factor. So, ibig sabihin yung load side natin dun sa left side of the equation that we have on the ASD side, kino-consider natin ngayon na lagyan siya ng factor na ang tawag sa kanya is load factor applied dun sa service loads natin. Okay? And the member will have enough strength to resist yung mga factor loads natin. In addition dun sa pag-multiply natin dun sa left side of the equation, we are also introducing a resistance factor, same like the function of the factor of safety. Pero ngayon, yung value niya is a value less than 0, less than 1 rather, na ang mangyayari, uh, ina-account din niya yung possible uncertainties dun sa mismong material strength natin. So, by incorporating tong dalawang factor na to dun sa both side of the equation, LRFD is said to provide a more realistic and adaptable design approach kasi ina-acknowledge niya na yung load and resistance natin are not constant and can vary from time to time. So, it delivers a more realistic or probabilistic na approach when we are trying to design our structure. So, kaya LRFD is considered to be more accurate and versatile than ASD, especially in dealing with complex and dynamic structural systems. Okay? So, um, ito naman yung formula para sa LRFD. Okay? So, for LRFD, katulad nung kanina, yung factor load natin, tinawag na siyang factor load kasi we have our actual loading, and then what we do is we multiply that actual loading o yung service load na tinatawag natin by a load factor. That load factor, as mentioned here, are usually greater than unity. It means na yung value niya is greater than 1.0. So, they try to amplify yung loading natin based from previous or historical data na na-experience ng mga designers before or na-observe ng mga designers before. Okay? So, as you can see, it is a summation of the loads and load factor. It means na for every load type na meron tayo, let's say for example, dead load, live load, wind, earthquake, and so on and so forth, these loadings have different load factors na ginagamit. Let's say meron siyang load factor for dead load factor for live load, for wind, and for earthquake. And then what we do is we try to have a combined effect of all of this loading and then try to compare it with our factored strength. Factored strength, it means na yung resistance or yung capacity ng mismong material natin, we multiply it naman by a resistance factor that is less than 1.0 to account for any uncertainties that may occur during the actual construction of our structure. So, by using these factors, sinasabi na yun nga, mas nasasaklaw ni LRFD yung actual condition na na-experience ng building once na na-construct na siya. And these factors are based from experience na we try to adapt so that we can create a more economical sections for our structure. Kaya yan yung tinatry i-work out nung LRFD na design philosophy. And again, for our course, we will be utilizing yung ASD and LRFD interchangeably kasi both design philosophies are advantageous depending on the structural component that we are trying to analyze and design. So, as we will be witnessing in the future, we will try to solve our examples using both design philosophy and then try to compare what are the sections that will be selected dun sa mga design natin. And then, try to distinguish which design philosophy is more advisable to use. Ano, or depending on your choice, kung ano yung mas tingin nyo na makakamura o makakasave ng mas marami yung ating clients when designing structures. Okay? So, to start with the computation of the loading, we need to review some of the factors that being stipulated in our code or yung NSCP natin, starting off with LRFD. So, in LRFD, ito yung mga factors o ito daw yung section na titingnan nyo sa NSCP para tingnan yung load factors natin. For LRFD factors, according to NSCP 2015, Section 502.3.3, for our required strength, okay, ito yung kailangang i-resist ito yung actual loading natin. May factor tayo, load factor, na multiplier, then may sarili siyang value, and then we have yung effect natin. So whatever is the loading that we apply dun sa structure natin, it should be less than or equal dun sa design strength natin. For the design strength, it will be the nominal resistance ng component natin o yung capacity ng material natin multiplied by a factor na again that is less than 1.0 para yung mababawas na portion na capacity dun sa nominal resistance natin will be for the uncertainties na pwedeng mangyari on site. Okay? So, to show yung different load combinations, NSCP provided us with section 203.3.1. According to this section, where strength design or load and resistance factor design is used, structures and all portions thereof shall resist the most critical effect. When we say most critical effect, ito yung hinahanap natin ngayon kung anong combination ng loading yung magpa-provide sa atin ng highest value. Kasi once na we designed our structure based from this value, the other load combo will be satisfied na. Okay? Kaya we are looking for the most critical effect dito sa mga following load combinations na to ng factored load. And for this load combination, ito yung mga suggested by the code. Okay? So, let us first enumerate yung mga loadings present. So, for D, we have yung dead load. For F, we have yung fluid pressure. For T, we have temperature. For L, live load. For H, we have earth pressure. LR is for roof live load. R is for rain load. Then, we have here a factor F1. F1, as mentioned here, is dependent on the type of live load that the structure is supporting. So if it is for floors and places of public assembly, 1.0 po yung gagamitin. And then for other types of live load, it will be 0.5. Then we have wind load and then earthquake. Okay? So, yan yung mga combo. Pero for our course, we will try to limit yung loadings natin. So, may simplified version po tayong ginawa dito. So, this is the simplified version that we will try to utilize for the course. Okay? But if your design, let's say in the future, you will be designing a retaining wall. Okay? So, if you're designing a retaining wall, you should consider itong H na value natin. So, you should include it kasi yun yung effect ng earth pressure dun sa structure natin. Pero, for in general, ito lang muna yung gagamitin natin for our examples and discussions in the design and analysis of the components that we will be handling this semester. Okay? So, to start, okay, again, this is LRFD. So, ang aim is for the loadings to be amplified. Okay, as you can see here, we have 6 set of loadings. And the first one, we have 1.4 for dead load. So, this load combo means that we try to amplify yung dead load by 40%. Unlike kay ASD, dead load lang siya as is na value. Let's say, may 50 kips kang load na dead load. As is na 50 kips lang yung ide-design nyo, gagamitin yung value. Pero kay LRFD, ina-assume niya na 40% more yung value niya. So, when we multiply yung 50 sa 40, so yung loading natin, imbes na ide-design mo siya sa 50, 70 kips na yung i-assume niya nag-a-apply dun sa load, dun sa mismong structure natin. So, by that way, kinoconsider nung first load combo natin yung possible overloading na mangyayari dun sa structure natin. So, ganun din yung nangyayari dun sa other set of load combos natin. And as you can see here, all of them or most of them are greater than 1. It means na we are trying to amplify nga yung effects ng mga loading natin dun sa structure natin. Okay? And then we have yung number 2. So sa number 2, it means na ang kinoconsider naman niya na possible mag-occur simultaneously yung dead load, yung live load, and yung roof live load or yung rain load natin. So as you can see here, the first two loadings natin, we have a value of factor na greater than 1.0 kasi kinoconsider ni AISC o ni NSCP na may medyo uncertain sila kung ano yung exact value na pwedeng mag-occur dun sa structure natin. Kaya to accommodate yung uncertainty, as you can see dito, yung sa live load, 60% yung dinadagdag niya dun sa regular loading niya. So, yun yung nakikita nilang way to capture yung any variations or overloading that may happen do sa structure natin. Pero dito makikita nyo sa pagdating do sa roof live load and sa rain load, imbis na i-amplify, 0.5 lang yung ginagawa niya. Ina-acknowledge din ni code na this particular combo is hindi siya bihira siyang mangyari lagi na present sila all the time. Like for example, sa roof live load. Sa roof live load, kailan lang ba siya nagiging present sa structure natin? Present lang siya kapag may maintenance, may kailangang ikaw i-kumplenahin doon sa mismong roofing natin. So, throughout the lifespan of the structure, this loading is not present. Kaya sabi ni code, wag natin ilagay ng buo yung loading niya as 1.0. So 0.5 lang o kalahati lang niya kasi it will not happen na these three load combinations will happen all at once. Yun yung gusto niyang sabihin doon sa load combo natin. Same with the rain load, ano? When we are talking about or looking at a load combo na may or doon sa statement niya, it means na these two load effects cannot combine or dapat magkahiwalay yung kanyang mismong treatment. So for load combo number 2, it can be further subdivided into 1.2D plus 1.6L plus 0.5 ng roof load, and then we have 1.2D plus 1.6L plus 0.5 nung nung rain load natin. So it should not be combined, ano, yung roof live load and rain load natin according to this combo. So yun yung gustong sabihin nung load combo number 2. For combo number 3, as you can see, do sa second and third term natin, may two load effects siyang pinagpapalit, ano? So it means na for load number 3, may apat na klase yan. So pwede siyang LR with F1 with live load, LR with wind, or rain load with live load, or rain with wind load. Okay? So ito naman yung another combo na naiisip ni code na possible mangyari din doon sa structure natin. And as you can see here, yung mga factors na yan are all decided already by the code. So these are based from previous experiences na hindi na natin kailangan baguhin. Okay? Kasi we just have to adapt kasi these are based from historical data na. Okay? And then yung F1 based doon dito again do sa mismong definition natin dito. Okay? And then number 4, same natin na discussion. And then as you can see for wind and earthquake, why do you think 1.0 lang yung value niya? The answer is when we are calculating for the value of the wind load and earthquake load na mag-act sa structure natin, may mga set of equations siya and may factors na siyang ginagamit. Ngayon yung factors na yon are all based from LRFD approach na. So ibig sabihin when we try to multiply a value more than 1 dun sa mismong load combo natin, parang nauulit na or over na, ano? So parang nag-overlap na yung number ng magnification na binibigay natin. So kaya nag 1.0 na lang siya. Okay? So dito naman naging 0.5 siya kasi inaano ni code na itong combo na to very katulad ng explanation sa number 2, hindi siya always mangyayari. May possibility na mangyari siya pero 0.5 lang or throughout the lifespan ng structure, maliit yung chance na mangyari siya always. Okay? And then we have here a plus minus. Okay? So we have a plus minus sign dun sa earthquake or even dun sa wind load for a very simple reason. Let's say this is the plan view of our building, and then we have an axis na pina-follow, bawa ito yung X and Y. So let's say yung earthquake load nag-act to the right. So that earthquake is considered as positive. So si code ina-account din niya na kung to the right yung application ng earthquake, possible din na ang movement ng ground natin during seismic activity is on the other side or doon sa pa-left yung kanyang effect, ano? So to accommodate that possible counter effect naman dahil iba yung direction ng earthquake, we need to see kung ano yung magiging value kapag naging minus naman yung effect ng earthquake sa kanya. Kaya ganun yung naging load combo natin dun sa earthquake at sa wind. And as you can see here, hindi din pwede magsama si wind at si earthquake kasi parang dilubyo na siya. Pag nagsama sa load combo, si wind load tsaka si earthquake load. So, ang ina-assume lang natin is may isa lang mag-govern sa kanya. It's either si wind yung mag-govern dun sa analysis natin or si earthquake yung mag-govern dun sa analysis natin. And then, for number 6, it can be seen here that we have a load factor less than 1. Maybe you're asking, why 0.9? as you mentioned earlier, sir, dapat more than 1.0 yung value ng load factor natin. The reason is when wind and earthquake hits our building, okay? So, halimbawa, ito yung ating frame ng structure natin. And then, may wind load or earthquake load, lateral load na nag-apply sa kanya. Yung movement ng ating building, so exaggerated, no, is like this. Okay? So, the lateral load tends to overturn yung structure natin, pero hindi siya nag-overturn completely. Dahil meron din tayong mga resisting or righting moment na nag-exist dun sa mismong building natin. So, the code assumes that not all of the weight ng building natin is tumutulong na i-overturn yung building. Some of them are helping our structure to retain or to go back to its stable condition. Kaya sabi niya, i-allot natin yung 10% for that effect. Kaya dito sa number 6, yun yung binabanggit niya. Whenever a lateral load happens, kinoconsider niya na 90% lang ng dead load yung nagiging usable kapag nag-overturn yung mismong o nagde-deflect yung structure natin. So, ito yung load combo natin for LRFD. Okay? So, again, this particular or different type of loadings are present to accommodate for all the possible effects or any scenarios na pwedeng mangyari dun sa structure natin. Okay? And then, so okay na tayo dito sa left side ng structure na ng equation natin. That is for the loads. Ngayon, para naman dun sa design strength natin, yung capacity natin, we have a factor. So, load and resistance factor, load resistance factors, according to NSCP, sections 502 through 511, it could be one of two values lang, 0.9 for limit state involving yielding or compression buckling, and 0.75 for limit state involving rupture. So, whenever we are tackling a new component, I will be presenting a value for the resistance factor. Pero ito yung main values na ginagamit all throughout the design. Okay? So it could be 0.9 and 0.75. But again, when we are discussing na a particular section or component, ibibigay ko ulit yung value ng resistance factor na gagamitin for LRFD para to avoid confusion whether yielding or buckling ba siya or rupture yung mismong limit state na ginagamit natin. Alright? So that is for LRFD. Now for ASD. For ASD, we are using safety factors naman, a factor of safety. So same din yung formula niya. However, as you can see, for the loading side, we do not have any factor or any multiplier that amplifies the effect ng loading do sa structure natin. All we have is a safety factor of safety that we divide dun sa capacity natin. And this value again is greater than 1.0. So when a number is divided by a value greater than 1, the value cease to decrease. So yung decrease in value, yung nawalang value doon are considered as allowance for uncertainties, again, for the possible errors that may happen in the future. Right? So ASD also has a separate set of load combo, as you can see. And apparent dito sa load combos na to ay wala siyang factor sa loading. Kasi sabi nga natin, unfactored yung load niya. Kaya service load lang talaga yung ginagamit natin. Pero as you can see here, may 0.75 na factor dito. It is also the same reason na maliit yung chance o yung possibility na always nag-a-act yung live load at roof live load at the same time. Same with live load and rain load throughout the lifespan ng structure natin. Hindi palaging mangyayari yung ganong combo. Kaya yun yung sinasabi ni Code. And then, dito we have 0.7 for earthquake. Kasi sabi ni Code, yung sa earthquake na equations na ginagamit to calculate yung value ng earthquake is considering na yung LRFD approach. So since naka-LRFD na yung mismong equation dun sa earthquake, hindi siya angkop dun sa ASD. Kaya sabi ni Code, to accommodate yung conversion from a value na earthquake na naka-base sa LRFD approach, 0.7 lang nung calculated value ng earthquake yung i-consider natin. Kaya para maging ASD siya, kaya naka-multiply ng 0.7 yung earthquake. And then as you can see here, again, plus minus para sa ating mga lateral loadings. And then tsaka mo na i-check yung effect ng mga yan base dun sa given problem natin. Alright? So, ayan naman yung ASD load combinations. And then we also have yung mga safety factors. So, ito yung dalawang value na present din. We have omega equals to 1.67 and omega is equals to 2.0. Okay? So, to apply this new concept ng ASD and LRFD, let's have an example. So, we have a column compression member in the upper story of a building subject to the following loadings. We have dead load of 485 kilonewton, a floor live load of 205 kilonewton, and also a roof live load of 85 kilonewton. Questions are determine the controlling load combination for LRFD and the corresponding factored load. So, yun muna yung sagutin natin. Letter A. So, in this type of problem, ang first goal is to identify what type of loading we are dealing with. Okay? So, as we can see here, for letter A, o yung ating unang given, so we have D, then we have L, then we have LR. Okay? So, to solve letter A, we will go back dun sa load combination natin. And then, we will try to guess aling mga numbers yung kailangan natin. So, si load combo, okay, hindi ibig sabihin na dead load, live load, at LR yung present dun sa situation natin. Dapat yung tatlong combination lang yung pipiliin natin. Dapat yung combination lang na meron tatlo yung kukunin natin. No, ang gagawin natin, basta present yung isang load effect o isang loading dun sa load combination, kasama siya dun sa consideration natin. Okay? So, ibig sabihin, si load 1, load combo 1 is kasama kasi may dead load tayo. Si load number 2 is kasama kasi meron tayong dead load, live load, and roof live load. Si number 3 is kasama kasi meron tayong roof live load. Okay? And then, dito, nangyari, naka or. Okay? Again, and then dito F1. So, since upper floor ng building, yung inano natin, assume natin na 1.0 yung value ng F1. Okay? So, if ever hindi present yung isang load dun sa combo natin, pwede mo pa din gamitin yung load combo. I-eliminate mo lang siya. Let's say, for example, sa number 4, wala tayong wind. So, pwede mong tanggalin yung wind. Okay? Pero, i-consider mo po ba siya? So, let's say, ginawa nating 1.0 to, L, mapapansin ninyo na this value na 1.2 plus 1L plus 0.5 is almost the same nitong number 2. Ang difference is 1.6 yung factor nito, ito ay 1.0 lang. And remember, ang hinahanap nating effect is maximum or yung governing value natin is the maximum effect. So load combo number 4 will not govern o hindi niya malalampasan yung value ng load combo number 2. So it will be a waste of time to calculate it pa. Pero if you are still want to calculate it, walang problema doon, ano? Pero again, as mentioned, critical o most critical effect yung concern natin. So maximum value yung kino-consider natin. Okay? Same explanation with number 5. Wala tayong earthquake, pero 1.2 and live load lang. So mas mataas pa din to kasi may 0.5 LR pa siya. And then dito, wala tayong value nitong wind at earthquake. 0.9 D lang siya, may 1.4 dead load tayo dito. So, hindi siya mag-govern. Okay? So, ang mag-govern o magagamit lang natin is this load combo yung tatlo. Okay? So, we have to write that one. So, dito ko muna isulat. So, load combo 1 natin is 1.4 dead load. Load combo number 2 is 1.2 dead load plus 1.6 live load plus 0.5 ng LR. And then, load combo number 3 natin is 1.2 dead load plus 1.6 LR plus yung F1 natin will take 1.0 live load. So, itong tatlong load combo na to, ito yung gagamitin natin for letter A dun sa problem natin. Okay? So, let's proceed dun sa problem natin. Okay? So, ito yung, again, yung ating mga nakuhang load combo. So, ang gagawin natin sa substitute lang natin yung mga values natin. So, 1.4 times 485.0 kilonewton. This is, kapag kinalculate natin, i-multiply nyo lang dun sa factor indicated dun sa problem. So, 1.4 times 485, that is 679 kilonewton. Then we have 1.2 times 485 plus 1.6 times 205 plus 0.5 of 85. So, calculate 485 times 1.2 plus 1.6 times 305 plus 0.5 of 85. That is 485, 1.6, 0.5 of LR, 205. So, it should be 205. Okay, so this is 952.5 kilonewton. And then we have here 1.2 times 485 plus 1.6 times 85 plus 1.0 ng 205. So, calculate 1.2485 plus 1.6 times 85 plus 1.0 of 205. The total is 923 kilonewton. So, comparing these three load combos value, okay, ang maximum sa kanya ay itong 952. So, ang sinasabi natin sa kanya, siya yung mag-govern. Okay? So, since factored load tayo, nire-represent natin ang subscript na U pag factored load. Therefore, ang ating RU is equals to 952.5 kilonewton. So, ito yung maximum loading natin dun sa load combos natin na yung gagamitin natin sa design. Okay? Next. So, sa letter B, ito ko na lang isulat yung letter B sa taas. Okay? Kung letter B, if the resistance factor phi is 0.9, what is the required nominal strength? So, yung criteria natin, dapat yung factored load natin should be less than or equal sa phi Rn. So, Rn yung hinahanap natin. So, to get yung Rn, divide natin both side by phi. So, we have phi. So, magiging Rn is greater than or equal to Ru over phi. Or substitute natin, we have 952.5 kilonewton divided by 0.9. Ang value of Rn natin, nominal resistance natin, divide 0.9, that is 1058.33 kilonewton. That is our Rn, yung nominal resistance. It means na dapat ito yung hahanapin nating capacity nung section natin kapag nagde-design tayo. Dapat at least 1058.33 kilonewton siya. Ano? Dapat that value or greater yung value. Let's say, a material na may thickness na 25 mm, tapos ang capacity niya ay 1,100. So, pwede natin gamitin siya for our design. Okay? So, that is how you do it. Yung pag-calculate ng governing load combo and yung nominal resistance natin. Next is yung letter C. So, for letter C, we are concerned with ASD load combo naman. So, punta tayo sa ASD load combo. For ASD load combo, ito yung pamimilian natin. So, ang mga kailangan natin, yung D, yung 1, yung 2, yung 3, and then yung 4 is pwede. Si 5 is hindi na kasi magka-cancel out to, so parehas na siya nung 1. Si 6, magka-cancel out to, so parehas na siya nung 4. And then si 7, hindi na din kasi mas less than siya dun sa number 1. So, ito lang yung gagamitin nating apat. So, we have LC1 is equals to D, LC2 is D plus L, LC3 is D plus LR, LC4 is D plus 0.75 ng L plus LR. So, yan yung gagamitin nating load combo para dun sa ASD natin. Okay? So, let's get back dun sa problem natin and then let's use another sheet. Okay? So, ito yung values natin. Okay? So for LC, so dito, ito yung 485 natin, kilonewton. Then we have 485 kilonewton plus 205. That is 690. Then we have 485 kilonewton plus 85 kilonewton. 485 plus 85, that is 570. And then we have 485 plus 0.75. And then kailangan pagsamahin natin yung 205 plus 85. 485 plus 0.75, 205 plus 80. So we have 702.5 kilonewtons. And based from these four values, alin ang maximum? Maximum natin or ang governing load combo natin is si LC4. Ito yung mag-govern sa kanya. So kapag ASD ang tawag natin sa kanya is yung governing natin na service load. Okay? Yung pinaka-service load strength natin. So RA is equals to 702.5 kilonewton. Okay? So ito yung sa letter C. And then ito yung magiging answer natin for the allowable load natin. Okay? And then last number, we have if the safety factor is 1.67, what is the required nominal strength based on the required service load strength? So using the same formula for stipulated for ASD, we have RA should be less than or equal sa Rn over omega. So kailangan ulit natin ay si Rn. Okay? So we need to do is cross multiply yung phi dun sa RA natin. So we have Rn should be greater than or equal sa phi RA. So that is Rn greater than or equal sa 1.67 multiplied by 702.5 kilonewton. So Rn should be greater than or equal to 117.3.175 kilonewton. So this is our value dun sa nominal resistance na required natin for our material. So yan po yan. So as you can see, mas higher yung value nung sa ASD natin. Okay? It means na kung capacity pinag-uusapan natin, pwedeng mas, halimbawa kung thickness ang consideration natin, mas thicker yung kailangan para kay RN kasi almost 1,200 yung kailangan niyang capacity. Unlike for the LRFD value, almost 1,100 lang. So, pwedeng mas manipis yung capacity natin dito. Pero we cannot really compare directly yung result ng LRFD to ASD. Ang pwede lang natin i-compare is once na we selected a section for each design philosophy, that is the time we decide which philosophy is more convenient for us. Kaya yun yung dapat tatandaan natin. Pero yung values niya should not be crossed with one another. So ibig sabihin yung result ng ASD, hindi mo pwedeng i-compare dun sa result ng LRFD. Sabihin mong yun yung nag-govern kasi magkaiba sila ng design philosophy. Ang consideration lang natin is for the end na decision if we will adopt a specific section na based sa ASD philosophy or LRFD philosophy. Okay? So, this is not always the case. Ano? It so happens lang na dito sa equation, sa example na to, mas greater than yung nakuha na capacity na requirement dun sa ASD. Pero since the code is still using si ASD and LRFD, we should check or verify both design philosophy dun sa calculation natin. Pero if the problem in the future doesn't say which philosophy we are going to use, the safest assumption is to use LRFD. Okay? Kasi some of, I think the latest AISC right now is not including na yung ASD kasi it is becoming part of a history na lang. Okay? Kasi the code is more advancing towards LRFD and plastic design na. Kaya maybe 10 or 20 years from now, totally non-existent na sa ASD, and then we will just be focusing on LRFD and plastic design for steel structures. Alright? So, yan po yung primer natin for design philosophy and the load combination that we will be using throughout the course. All right? So, again, for questions, just leave out your comments and then I'll try to get back to you when I have a time. Okay? Thank you for listening.